any type of, chemical experiments, we can use observations that we observe in the lab to come up with all the relationships that we discuss in our textbook. So the way that my freshman chemistry professor explained this to me, and he emphasized this all the time, and I try to reiterate this, is that chemistry is an experimental science where measurements are made. So in terms of what happens in electrochemistry, if we look back at some of the observations and experiments, we need to come up with our theories from those particular experiments. So let's look at a few observations. So we're going to take observation number 1, where we take a strip of copper metal, which is a solid, and we are going to immerse this copper solid in a zinc solution. So our solution here is going to be zinc 2+, and let's just say we have a 1 molar solution. If we allow this to sit here for a little while, nothing happens. And nothing too fancy, nothing too exciting. But if we take and manipulate the conditions of this experiment and talk about observation number 2, if we took zinc solid and immersed this zinc solid in a copper 2+ solution that was 1 molar, we would begin to see these little, dark dots starting to form on the surface of this zinc metal. And the more time we allow to go by, the more of these dots are going to start forming. And they start growing on the zinc metal. So observation number 2 is that tiny black dots form on the zinc solid surface. So we have to come up with a reason, or we have to figure out exactly why these black dots are forming and come up with a theory explaining what is happening here. One of the theories that was introduced was, well, maybe we take the copper 2+ from the solution. If we add 2 electrons to this, we will get copper solid. And that copper solid is going to form on that zinc layer. So if you think about this, and in any type of experiment or any type of lab observation, you come up with a hypothesis or a theory. We can use the scientific method to test that theory. And the question is, how could we prove that it's copper that is depositing onto that solid surface? And what type of instrumentation would you have to use to prove that? So if, for instance, this copper 2+ gets converted to copper solid, the concentration of the copper 2+ is going to decrease. So if we were measuring concentration, what would we have to do to go into the lab to prove that this happened? We can use an absorption spectrum or look at our spectrometers. So if the concentration of the copper drops, that means the absorption spectra will change. And if we were monitoring the progress of this particular reaction, we could see that the copper concentration will change in this particular case. If we let it go for an hour or two, we could visibly be able to see this from our eyes, because if we're using 1 molar copper solution, it's going to be this deep blue color. And as that concentration drops with time, it's going to get a lighter color. We can do the same thing in the zinc case, because when we look at these particular reactions that are happening, we talked about the law of conservation of energy in the thermodynamics unit. What we also have to conserve is the number of electrons. We can't just create them out of thin air. So if this copper 2+ gets converted to copper solid, we need 2 electrons. We need to get that from something else. So in this case, zinc solid is going to produce zinc 2+ ions in solution plus 2 electrons. So the electrons can be transferred from that zinc to the copper. And just like energy, and we can transfer energy from one form to another, we can transfer electrons around. If we have a transfer of electrons, we define electricity as the flow of electrons. If electrons are flowing around, then we can somehow try to figure out, hey, can we build something to harness this energy or to capture this energy to run different type of electronic devices? So that's kind of what we're looking at, and we have to kind of, take a couple steps back before we get to batteries, because we will talk about them at the end of the chapter. But let's look at these two observations. Okay, one thing that I will note here as well, our zinc 2+ in solution will go up. And again, an absorption spectrometer will allow us to figure out just how much it went up. And we can start collecting data for all of this stuff. One key thing to note here, and once we've kind of set the foundation for this thermodynamics unit and we talk about energy, that opens the door for us to talk about a spontaneous process in pretty much any way, shape, or form. So we can say that in observation number 2, we have a spontaneous reaction happening. Observation number 1 is not spontaneous. So we can kind of come up with some type of a way to show this relationship. And how can we use some type of electrochemical potential, or how can we capture this flow of electrons to try to, create some kind of cell or some type of battery? So let's kind of go a little bit back in history. This stuff right here happened in the early 1800s. And one of the pioneers for electrochemistry was this guy named Sir Humphry Davy. And at the time, Ben Franklin's out flying kites. People were trying to figure out what's going on. We know if we rub some things together, you've seen electricity stuff as a kid. You rub a balloon on your head, it sticks onto the ceiling, then it'll eventually fall down. What's happening here? What happens is we take some metals and kind of rub those together. So in terms of how research works, unfortunately we can't perform some of these experiments and say they're research, because they were already done back in the 1800s, and the tables that we use today had data that started to be collected back at that time. So back in these 1800s, these chemists tried to get money to fund their research, just like we do today. You guys are going to be doing a poster for your real project. That's usually step number 1 to start presenting your research. You usually come up, a couple weeks ago you wrote a proposal. That proposal was for a particular project that you were going to do, but you can also write proposals for money. Back in the day, they didn't write proposals for money. They actually had to go and give a presentation to someone. In the 1800s, Napoleon had a lot of money, and he typically gave all this money that he had to the French. But Davy was a little bit different, because he came and gave this presentation and completely blew Napoleon away. Davy was very, very famous for giving these awesome lectures, And basically they found out later, oh, this guy's hilarious. Every time he gave a lecture, it was so funny. Well, he used to spray nitrous oxide around the lecture hall, and everybody thought his lectures were fantastic, right? They're laughing out of their chairs. So if you begin to smell something in a couple of minutes, that's probably the nitrous oxide that we're spraying in the room here, right? So he did that, though, and he comes and presents to Napoleon, lines all these monks up. He has his little electrochemistry kit that he's building, and he goes and shocks one of them, and they just jump, right? Then he kind of ramps it up a little bit and goes down the line, and the last guy really got shocked. Napoleon thought this was freaking hilarious, right? So he funds this research for him. And what they're doing here is we can use metals to somehow create electricity. And we might not be interested in shocking a bunch of people, but we might be interested in somehow storing this together and making a battery so we can power an electronic device. So how did we get back all the way from the 1800s till now? Okay, so